All right, so we all use the internet every single day, right? You click a link and boom, a web page just appears. It feels like magic. But today, we're going to go behind the curtain. We're going to look at the actual physical infrastructure, the wires, the routers, the hidden rules that make the whole thing tick. Let's get into it.
Just think about the last time you bought something online. You hunt for the item, you add it to your cart, you click that final buy button, and instantly you get that nice, clean, order confirm screen. It feels totally seamless. But that confirmation page, that's not the story. That's just the happy ending. The real story is the incredibly complex journey that happened in the milliseconds before that page showed up.
And this quote, right here, this is the mindset shift we have to make. In cybersecurity, nobody really cares about the shiny confirmation screen. That's irrelevant. What they care about is the truck that's delivering the order. What route is it taking? What stops is it making? Because if you can control the truck, you control the delivery. You control everything.
So that's exactly what we're going to do right now. Think of it like opening up the network tab in your web browser, but for the entire planet. We're going to see those invisible trucks and the digital highways they travel on.
And the basic tool we use to do this is a command called tracerroute. It's pretty simple, really. It's like asking your computer, hey, to get to Google's homepage, show me every single hop, every router my request has to stop at along the way. The results are, well, they can be pretty eye-opening.
What's wild is that this simple tool is a classic double-edged sword. A defender, the good guys, they use traceroute to make sure their network traffic isn't taking some weird, unexpected detour through a country it shouldn't be. But an attacker, they use the exact same command to draw a map of their target's network, looking for that one weak link, that one old server that they can use to break in.
To really understand what we're looking at with a traceroute, we need a good analogy. And honestly, the best one, the one that makes all of this technical stuff just click, is to think of the entire internet as one giant global postal system.
So, let's start with the basics. Your IP address. This is easy. It's your home address, but for the internet. It tells every piece of data out there exactly where to find your computer on the map. It doesn't say who you are, just where you are.
Now that's different from your MAC address. If the IP address is where you live, the MAC address is who you are. Think of it like a social security number for your phone or your laptop. It's a unique serial number that's physically burned into the hardware. It identifies the specific device, not just its current location.
And what's being sent through this postal system? Packets. You see, you can't mail an entire book in one go, right? You'd have to tear out all the pages and put each one in its own separate envelope. The internet does the exact same thing. Every photo, every email is shattered into thousands of these tiny little pieces, these packets, to make the journey.
And the routers? Well, they're just the local post offices. A router in your town has no idea what the full route to Tokyo looks like. All it knows is how to get that packet one step closer. It looks at the address, says, okay, for that destination, you need to go on this truck next, and sends it on its way to the next post office.
Okay, so we've got the postal system analogy down. But what's actually written on these digital envelopes? A data packet is more than just the message. It's kind of like a Russian nesting doll, with layers of information wrapped around other layers of information. This whole process is called encapsulation. So at the very center, you have your actual message. Then a layer gets wrapped around it that adds a sequence number so the computer on the other end can put all the pages back in the right order. Then the next layer gets wrapped around that, adding the final destination IP address and the return address. And finally, the outermost layer gets added, which only has the address for the very next post office on the line. Each layer adds a new set of instructions.
But here's the kicker. One of these layers, the network layer, the one that contains the source and destination addresses, has a huge, fundamental flaw baked right into its design. And that flaw is a massive target for attackers.
The attack is called IP spoofing. And with our postal analogy, it's actually super easy to understand. All the attacker does is write a fake return address on their malicious envelope. The server they're attacking gets the packet, looks at the return address, and thinks, oh, this is from a trusted friend inside my own network. So it lets it right past the defenses. It's the digital equivalent of a Trojan horse.
And this simple trick of faking an address points to a much bigger, almost philosophical truth about how the internet is built. We tend to think of it as this robust, engineered system, but in reality, it's more like a giant house of cards built on a very fragile foundation.
That foundation is a system called the Border Gateway Protocol, or BGP. And you can forget the technical name, just think of BGP as the internet's rumor mill.
There's no single official map. Instead, the big routers that form the backbone of the internet are all constantly gossiping with each other, shouting out, "Hey everyone, I've got the fastest path to Google," or "Send your YouTube traffic through me."
So what happens when somebody in that rumor mill lies? With an attack called BGP hijacking, a big network, say a state-controlled internet provider, can just start broadcasting a lie. They can tell the rest of the world, "Hey, just so you know, the fastest way to get to Google now runs through our servers." And because the system is built on trust, other routers believe them. They start rerouting huge amounts of traffic right through the attacker's network, letting them spy on or even block data at a massive scale.
And this brings us to what might be the single most important takeaway from all of this. The early architects of the internet didn't design it to be a fortress. They designed it for collaboration and speed, assuming everyone on the network was a friendly academic. The internet is fundamentally built on a foundation of trust. And in cybersecurity, trust is always a vulnerability.
So, let's just quickly recap. We've learned the internet isn't some magical cloud. It's a very real, physical system of cables and machines. We know our data doesn't just teleport, it hops from router to router. We know the key difference between our IP address, our location, and our MAC address, our identity. And most critically, we've seen that the internet's very foundation was built for trust, not security.
So, we've mapped the highways and we understand the postal system. But knowing someone's street address is kind of useless if you don't know their name to begin with, right? So now that we know how the roads are built, what about the internet's phone book? That's what we'll be diving into next time. See you then.